Alright guys, so we finished our haunch connection detail. Just remember that this haunch here is used to increase our structural rigidity of our portal frame. So let's come back to our section. Okay, I'm just going to rename this while we're here to be our portal frame. So right click, rename. This is our portal frame. Okay. Now what I need is a detail about our base plate. So I'm going to come to view, call out, and I'm just going to put one around here. Right click, go to view. So what I need to see here is I need to firstly change my scale 1 to 20, detail level to fine, graphic display as shaded. Okay, just like everything else. Now I don't need to see the girts here. All I want to see is my column, my hold down bolts and base plate, and my pad footing. So I'm going to hide my grid line. I can bring it back and use a center line down the track. We'll get down to that after. And what I'm going to hide as well is these girts. I'm not interested in seeing them just yet. They don't have any value adding to this detail. So I'll just tidy this up. Now what I'm going to do is increase my area for my annotations, and then I'm going to turn off my crop region. So what I need to do is I need to be able to see these bolts through here, and I need to put in some bottom reinforcement. So I'm going to select my pad footing. Now I know we haven't covered concrete yet, but we'll go through this now, and then we'll get into the nitty-gritty details of concrete in the next couple of weeks. So we can specify structural material. We can put in, say, 32 MPa concrete. I'm not going to worry about that as of yet. What we're going to do is make it transparent. So select it, right click, override graphics in view by element. You can do this from your visibility graphics, so VV or VG, or go through the view tab and grab it that way. Okay, now all I'm going to do is make it a little bit transparent so I can see the bolts. Go OK. And now what I'm going to do is put in some bottom reinforcement in here. Okay, this is going to be all under tension, this bottom area below the neutral axis. So I need to go structure, rebar. Now what I can see in here is I have all these shape M's. Okay, so by looks, I don't have an Australian family loaded in here because I know the rebar shape S is what I'm after for the longitudinal bars. So I can use this rebar shape M, so the longitudinal bar, just a round circular bar. But in my properties, what I can see is I don't have my N bars, my N12s, N16s, N24s, 32s. I haven't got any of them. So what I'm going to do is load shapes. This here is going to be Australia. I come down to structural rebar shapes. I'm looking for my shape S. Okay, go open, and this is okay. So the first thing I want is I want to run the bars in the X direction. So parallel, so I can see it like this. Okay, I need to change my properties. So I'm after an N12, so N10, N12 bars. All right, now this will, if I place this here, this will give me 1 bar. So I come to my modify tab, go to my rebar set, my layout, I'm going to change these to a maximum spacing, and I want each of my bars to be 150 centers. So all of this information will be given to you by a design engineer. Okay, now I'm going to put the bottom ones here in one direction. Now this is a 3D object, and this beam or this pad will bend in 2 directions, so I need to reinforce it in 2 directions. So I need to placement, and I change my placement orientation to perpendicular to cover. so I can see my bars in the opposite direction, kind of like our slab mesh. So I'm going to put these, I'm just going to place them on top of my bottom bars, and that will be okay. That would be 150 in one direction centers and 150 centers in the other direction. So if I come to my 3D view, it should be this footing here. So I'm just going to show you what it looks like. I'm going to make my footing transparent to start off with. And then I'm going to select these bars. Okay, we'll get into this when we do it a bit more concrete, but as we can see, this is very in a 2D just lines. It's actually 3D bars. We come in the properties, graphics, there's view visibility states, we edit, and in my 3D I want to view as a solid and view unobscured. Go OK, and now I can see these as an actual grid. I can make it realistic and the bars will show a bit better. So this is how they look in here. So they are 3D bars overlapping on top of each other. Okay. So we can come back to our detail. Okay, now we've got everything in here that we need to start putting in some text. So this column here is column 1 or column type 1. Okay, we will have separate pad footings because we have smaller ones for our second columns. Okay, if you remember from our 3D, these pads here is what I'm talking about. These pads and columns are different to these pads and columns. So what I will do first is annotate text. And this one here is C1. Okay, and it's also going to be 3.5 millimeters in height. C1. Okay. Now, what I need to do is start to detail the rest of it. So, text. Now, remember we have our base plate, and underneath our base plate, we have this non-shrink grout that we have to use. So I'll just double check. I think we've used a 30 millimeters. 30? Awesome. So I will go text, and I have 30 millimeters non-shrink grout. Okay, I'll move that up a little bit. I'll put a leader to the left, and my non-shrink grout is sitting down here. Okay. My base plate, which is here. Okay, if I go tab, I can pick the actual plate, check my thickness, it's a 20 millimeter thick plate. So TX, what I have here is a 20 millimeter base plate. Leader to the right, and that's this plate here that I'm talking about. Awesome. So the next thing I want is I might specify my bottom reinforcement here. So TX, and I have N12 bars. They're 150 centers, and that's in both directions. Space there. Okay. So select my text, leader to the right, and that's these bars here that I'm talking about. Okay. Now, the other thing that I have to specify is my pad size and my bolts. So I might put the hold down bolts over here. So TX, and what I have here is I have 4 M20. Now remember, these bolts are different. We use non-structural grade, so we use 4.6 grade bolts for our base plates because high tensile strength are good in tension, but if you try to move them as they're set in concrete, they tend to snap. Okay, they're very brittle. So we use 4M20, 4.6, and these are our hold down bolts. Hold down bolts. Okay, I'll just move that here, lead it to the right, and that's these bolts here that I'm talking about. Okay, I try to keep everything straight when I'm annotating. Okay, we don't like to have curvy lines anywhere. And last but not least, we have our pad size, and then we have to put in this break line for our column as well. So text, and this one here, I'll just double check. Sorry, I forgot to check the bolts. So tab, check the bolt. It's a 4.6 M20 bolt. Awesome. And the pad is 1700 by 1700 by 900. Okay. So TX, our pad footing is going to be 1700 by 1700 by 900 pad footing. Okay. We can specify the concrete grade and things like that in our notes elsewhere. Last but not least, we have our break line to put in here. So annotate component, detail component, and this one here. Okay, notice I didn't rotate after placement for this one. And I will just tidy it up just like we did before, just so it looks a bit more proportional to the rest of our drawing. And I might just increase that a little bit, just push it a bit further up. Awesome. Okay, just a little bit of final tidying up. Now that looks alright. Now I can check how I went with my annotation crops, and I can pull them back in if I need to. Oh. And then that one comes down. Alright, my crop region undone again, and that is our base plate detail for our column 1. Okay, so portal frame, rename, this is going to be our typical base plate connection detail. Okay, so that is how we do this one here.